Hello, everyone. I'm David from the Packet Stage. And today with me in this video, I have Moaz and Rad. Thanks for joining. We are going to discuss the container registry and the dependency proxy. It will be like a walkthrough. So now to set expectations right, we are going to look at the container registry and dependency proxy, but on the Rails side, sorry, not on the container registry directly. So I will start with the container registry, then we will go into the dependency proxy, and yeah, that will be it. Don't hesitate to interrupt me if you have any questions or anything. So the container registry, yeah, at its core, it's quite similar as a package registry. So it's like managing a bunch of images, images. And that registry is really targeted to Docker clients. So you have the official Docker client. I guess some other clients exist too. And so those clients will push and pull those images from the registry. Now, the difference here with the GitLab package registry is that the container registry, the GitLab container registry, runs on its own backend. It's not on Rails. So it's you have the Rails core of GitLab, and then you have the container registry, the GitLab container registry backend running on the side. So that's already a difference. Now, why do we have container registry features on the Rails side? Well, the thing is that the Docker, I will say Docker client, but it can be any client. The Docker client will try to do operations with the container registry, so directly with the container registry without going through the Rails backend. And the container registry will ask for authentication. Yeah, you can imagine that pushing an image, that's not something that an anonymous user can do. So the container registry doesn't have any authentication set up internally. What it will do is, hey, you will need to get a token from here. And the here is the Rails backend, because this way we can leverage all the authentication and all the permissions system that we have in the Rails backend. So let me show you a diagram. It is. So basically you have the Docker client, the GitLab container registry, and the GitLab Rails. As I said, the Docker client will try to like do an operation. In this case, it's like as simple as a ping. And the container registry will reply, hey, you need to have a token to do this. So look at this URL and get a token from there. And this URL, it's the GWT controller from the GitLab Rails. So on the next request, the Docker client will just do what it has been instructed to do, which is get a token from GitLab Rails. And then Rails will reply a token if everything was okay with the permissions. And then we will, the Docker client will redo the exact same request, but this time around, it will provide the token, the authentication. And so the container registry will accept this if all goes well. So what you need to see here is that even though those are two different backends, we still use only one permissions authentication system, and that's the one from GitLab Rails. You can easily understand why, because on the GitLab Rails, you can have permissions on like groups, and you can cascade the permissions in the contained projects and things like that. So we have a set of specific permissions for the container registry. I think it's read registry and write registry, or read container image and write container image. And those permissions will leverage what we have in the GitLab Rails backend. Is there anything else? No, I don't think. We can take a look at this JWT controller. So this is a general controller that basically will create JWT, well, JSON web tokens for a given service. So usually what we expect is a service parameter that will tell that clients we use to say, hey, I want a token to access this service. And you can see here that we have a service dedicated for the container registry. And then we have a service for the authentication. So the controller, at its core, the idea is really read the service parameter and then distribute or locate the right authentication service, and then just execute the service. So we do have one for the container registry, and we do have one for the dependency proxy. Yeah, we will see when we discuss the dependency proxy, but the authentication works exactly the same way. So that's why it's there too. If we take a look at the container registry authentication service, it's here. Well, it's nothing too magical. I mean, we do have the permissions, and then we will use the declarative policies that we have, like the project policy or the group policy, to evaluate those permissions against the provided user. Do we see this here? Yeah, we do have the username, but I'm pretty sure that the JWT controller needs to be authenticated. Like the request you do needs to be authenticated. Okay, so, well, actually we can see it here. We should have, you see, we have an HTTP basic. So we will receive from the Docker client the username password. We will locate the user, and then it's just, but it's a pretty complex service. So it's not that just, it's not that simple, but it's a matter of taking the user, we also receive the path that the client wants to access. So we can even locate the project, and then we evaluate the permissions. This user has the permission to like push a container image on this project, yes or no. And then we reply a token. Actually, that's an important point. Even if it is a no that we get, we still reply a token. But what the actions, the allowed actions will be is the empty array. Like this user doesn't have any permissions or any actions that the user can do. So even if we don't reject failed authentication, that's the point. We always reply a token, no matter what. So either the token is properly filled with the actions that the user can do, or the token is like empty. Because at the end, that's just a token. The one that will decide if the request goes through or not is the container registry. When it receives the token, it will, well, first like it's not authenticate the token, but there is a shared secret between those two backends, and that shared secret is used to sign the token. So it will verify the signature of the token to make sure that, yeah, it is a token generated by the GitLab Rails backend. And then it will look at, okay, this token is now a valid one. Let's see what actions the user can do. Oh, it's empty. Well, nope. This request will not be a 200. Okay, it will be something rejecting the action. But how we reply to a Docker client that the action is rejected, that's the container registry responsibility. So in this request, this one, the 5, that returns the token, you will always have a token, even if you fail the authentication. Like the user doesn't have the right to do whatever he wants to do on the project. That's a pretty important difference. Usually in the GitLab Rails, if like it's not authentication, it's more authorization. If the user lacks the right permissions to do an action, we will just like bail out, reject the request, and just answer, no, you can do that, like a forbidden response or something. That's not the case here. We will always return a token. Okay, so that's the authentication, which is already, well, different. Then we have data. That's an interesting part. But before that, do you have any questions on this authentication, like interaction schema or anything else?
I'm curious why we always reply with the token. Is that a standard that we need to comply with?
Yeah, if I recall correctly, the Docker like standard will require to always reply a token. Can do a quick check. Yeah, it's this thing. Yes, I can put it here. Yeah, that's tiny. Let me zoom in. So this is the like token spec, or what the token server needs to do to be able to be used by a container registry as a authentication server. So you have the actions you can do, things like that. But one thing that is really important is this one. Yeah, if because when we receive this request to create a token, we receive the array of actions that the user want to do. So it can be pull, it can be push, it can be, well, whatever. If the client has only access to a subset of this requested access, that must not be considered as an error, because it's not the responsibility of the, well, token server to say that this is an error. Instead, what we do is that we intersect the requested actions and the permitted actions. So if you request for example, for a pool, and the user doesn't have access to pool, it has access to, well, something else, but not pool. If you intersect both, you will get the empty array, and that's what you need to return. Does that answer your question?
Yep. Thank you.
Okay. Yeah, data. Yeah, I will simplify a bit. it's way more complex, but I will simplify the data on the container registry as repositories and tags. So repositories is the path of an image, and then you can add tags to this path, and you can create different tags to a repository. So only two models that you have a repository that has many tags. It's way more complex than this, but for the explanation, it's enough. The main thing here is that, as you can see, the only interaction that the Docker client has with the GitLab Rails, it's only for authentication, and that's it. What happens here, like the actual action of the Docker client, we don't know. Rails doesn't know, better said. Container registry knows, of course, because it has to like execute the action, but Rails doesn't know at all. So there is a challenge, and this is the core of the complexity of the data regarding the container registry, is that Rails doesn't know about all the data that the container registry has, because we are only, like, Rails is only called during the authentication. So it's before my time. I don't know why it has been made like this, but I guess on the Rails part, we wanted to have like a best effort. So what we do is that actually when you receive a request for authentication, you receive the container repository path, so you can locate the project and the name of the container repository. That's actually the path, and we receive the action. So if we detect that there is a push action to a container repository in a project, well, here we are going to create a container repository object in the database. There is one container repository here. This is the model. The main problem is that this is authentication, and this is the actual action. So authentication can be successful, and you could be creating a container repository with the path and everything, but the actual action could fail. For example, a network hiccup or whatever. So again, I think this was done as a best effort, so that Rails still know, okay, on this project, we have that many repositories. But it's not guaranteed at all, because the action can fail. So you can have a sync issue between what are really the container repositories that actually exist and the ones that are in GitLab Rails. This has always existed. Most of the time it works, but just be aware that when we create a container repository in GitLab Rails, that doesn't mean that it will be created in the container repository, because Rails is before the actual action that can fail due to, well, whatever problems you can like assume or guess. So we have the container repositories. Most of the time, it's okay. What we have in Rails, it's what we have in the container registry, but it's not guaranteed. There is no guarantee to that. So now I said that there are container repositories, and then they have many tags. Each container repository has many tags. These tags objects, they don't exist in Rails. Rails doesn't know when you, like, if you load, not this one. if you load the container repository, there is no way to know how many tags or which tags are available here on this container repository. The only way to know it, and I assume that there is a dev tags. Yeah, it's here. The only way to know it is to, we'll take this schema back. It's to contact the container registry to say, hey, I have this repository. Let me know what are the list of tags. So the container registry declares an API that we can use to inspect container repositories, like inspect tags, have information on the container repositories, have information on each tag. And the GitLab Rails will like heavily use that to build the data. So yeah, that's pretty the core of the challenge is that anytime that you work with tags here in Rails, it's challenging because we don't know the tags. Container registry knows, but Rails doesn't know. And to know it, we need to contact the container registry. So you can imagine that we have a few challenges. For example, when you open the project page and you go to the container registry and then, well, actually, let me see if I can find, well, we do have an example, that's for sure. Here. So that's the GitLab. No, that's not actually where I want it to be. Here. Okay, so container registry. Those are the images, and you can see the amount of tags. So just imagine building this UI. This UI can't be built only on Rails. It's impossible. Why? Because we have the amount of tags, and that amount is not known by Rails because we don't have the tags object. So to build this count, we like for each image, we contact the container registry and say, hey, what is the list of tags that we have here? And that's why you see that there is, I don't know if you noticed, but like the tags count is delayed from the main loading of the page. That's because we have to query the container registry. And this is a challenge in all the features that we build in like the UI, API, and whatever in Rails. Because like, for example, I think one of the things we wanted to do is like filter the results. Well, it's not simple in the sense that this is not a database query. It's way more. We need to locate the repository, then we take the search input, and we need to get the tags from the container registry. There is no search API endpoint there, so we get all of them, and then we apply the search on it. So this action it's actually like several interactions orchestrated between Rails and the GitLab container registry. So it's not like the usual Rails search function where you end up with a database query with the I like statement or something like that. No, because tags doesn't exist in the Rails database. Yeah, they are not there. They are on the container registry. So we need to use the API. So to do this, a very specific class has been built, which is the registry client. Yeah, well, client RB. That's the client that will implement the container registry API. So we have a few endpoints, like for example, tags. You see the list of tags of a specific repository. That's a function. We have other functions like the digest or deleting things, or well, it's an API endpoint that, well, it's a API on the container registry that we implemented in a single class. Do we have anything else here? No, that's the main point. We do have the container repositories on Rails, but not the tags. Anytime you do something with the tags, there is a container registry access all the time. That's why it's challenging for those features. Okay.
Yeah, I have a question here.
Yeah.
Why we don't just store the count of tags, for example, in our database? I mean, it's easy to fetch those numbers and store them in Rails. So every time a user is going to the page of the container registry, then the count is in the database, not to fetch them from the container registry each time.
Yeah, I guess it's doable, but then it's again the same thing. If we look at the interaction, like let's say that you see a push for a repository and the tag, you can increase the count, but that count is not guaranteed because the real action happens after. So yeah, I guess it's possible, but it's like it will not be reliable. So how much of this reliability we want, I don't know. That would be a discussion with product and the container registry folks. But that would be possible. We could also even perhaps push further. I don't recall exactly if we see the tags here. I'm not sure. If you see the tags, if you see the tag like, hey, I'm pushing tag latest on the container repository, we could create a tag object on the Rails side. But that might be not the case. Otherwise, I don't see why it hasn't been done already, because we already do that for container repositories. So why not do that for tags too?
Yeah.
But yeah, on the count side, that could be possible, I guess. You will see, perhaps in some parts, we have even tried to use some caching, in the sense that for some requests, we can just quickly like cache a prior request to the container registry and reuse that result instead of pinging the container registry again. We tried that, it worked quite well. Nowadays, we do have something else, which is, let me see if I have it here. No. Oh, it's this one. So I said that the container registry provides an API. That's the standard Docker container registry API that Docker owns in a way. It owns that spec. So for example, the endpoint that returns tags, well, it returns all the tags names. Like if you have a massive amount of tags, you will get all of them, but only the names. If then you want any details on any tag, there is another endpoint where you ask the container registry, hey, I want the details of this tag. So like things are even more challenging in that situation. But that API is like owned by, not owned, but like it is standardized by Docker and they have specs. So it's not like we can move around this API. So for our needs, yeah, I will speak a bit on the history of the project. We created yeah, thanks. I ask you to open this. We created another API that runs like side by side on this API, and this other API, well, we call it the GitLab API. I don't know if that makes sense, but it's basically the container registry. The GitLab container registry has the like Docker API like from the beginning, like it is even referenced here. And you can see that it is like, they have a spec for it. But we decided to have like an API for any GitLab need. And for example, if we take the tags example back on the Docker registry API, it was returning tags, all the tag names more precisely. So it's like receiving a giant array with all the tag names. So imagine that you ask the amount of tags, the list of tags for this one. That's that's a pretty huge array. So what we did, we created like a GitLab API. We call GitLab because it has a GitLab prefix. Let me see, compliance check. Yeah, you see there is a GitLab v1 prefix. So I call it the GitLab API, but perhaps that's not that correct. And here we were talking about the tags. You can see that we created a like give me the list of tags, but this time around, like there is pagination available, so we can like walk the tags in chunks, and we do have more information than just the name, because like just the name, it's not like you can do a lot of things. So let me show you the body. Here it is. So for this example, we have two tags here. On the Docker API, that would return a single array with like this name and this name. That's it. If you want anything else, like the digest or the timestamp, the creation timestamp, you need to ping the container registry again for each tag. So building this on Rails using just the standard API or the Docker API, we would have one request to get the list of tags names, one request for each tag, that would be 2. So you are already at 3 requests. Yeah, well, apply that to this amount of tags, and you can see that you are like exploding the amount of requests done to the container registry. In this API, the GitLab API, it's tailored to our needs. So it will return in one request, like the name, the digest, the timestamp, and so it will be one request for everything. And it's paginated, so we can walk this amount of tags in like chunks instead of trying to return everything in one go. Well, I will not go into much more details, but we do have like several API endpoints for GitLab needs. And on this API, since it's GitLab, it's like we are free and way more flexible. We can create any endpoint that we might need or anything. Yeah. Will I speak about that? Yeah, I guess I can. So because we have a GitLab API, we do have, you remember that we have a client to talk to this API on the container registry? Well, no, that was not. Yeah, it was. So we do have the GitLab API client. Yeah, I created this class, so if the name like isn't great, that's my fault. Yeah, happy to have a mouse with a better name. But basically, we are implementing all the endpoints I just showed you in the documentation. For example, the tags list. Where are you? Tags list. Yeah, here it is, tags. And this time around, we have like a page size and everything. So we have 2 clients. At this time, at this time of the presentation, users can, well, not users, on .com, we are going to use the GitLab container registry. On self-managed, they have the choice of using any other container registry. But that is a problem because that container registry could be like the Amazon one or something else, will implement the Docker API, but well, obviously it will not implement this GitLab API. And so that's why for some operations, you will have a service that is a facade, and that facade will select the correct implementation depending on which container registry is connected to GitLab Rails. Example, I think it's delete tags. Yeah, that's the one. So here it's a service that will receive a container repository, and then it will try to remove tags. Oh yeah, from a list of tag names. So you give a container repository and the tag names, and it will send the delete requests, many or a single one, depending on which container registry is connected. And you can see here that depending on which container registry is connected, we will use the GitLab API. So we have a delete tag service, but under the GitLab namespace, and then we have third party, which is like anything else. And so for anything else, we can't use the GitLab API endpoints. We need to use the standard Docker API. So I guess, can we see D here? Yeah, you can see here that we are accessing the client, which is the very first client class I showed you, which is the Docker API. Whereas if I look at the GitLab namespace, yeah, well, there is an util function, but this function will use something that is only available on the GitLab container registry. So you can see we have a bunch of things that are divided in two, depending if we are connected to a GitLab container registry or something else. That's something to keep in mind while working on new APIs or things like that. That's the current status today. If one day we are going to drop the support of third-party container registries, I don't know. I saw some discussions about it, but I don't know if that will happen. What I know is that if that happens, well, there are a few things that we can drop on the Rails side. But until then, we need to support both APIs. And well, usually you can easily guess that using the third-party API, the Docker API, is usually way it's less efficient than using the GitLab API endpoints, because those endpoints are tailored for our needs. So, for example, in this case, it's customized for deleting tags in an efficient way instead of this one. So those services below third-party will like trigger more requests to the container registry or do things in a different way that is less efficient than these ones. Is that all clear? I'm checking the time. Yeah. I have two more things on the container registry, and then we can go to the dependency proxy. But since we spoke quite a lot on the container registry, I guess the dependency proxy will be a bit faster. One thing I want to show you is the cleanup policies. I will probably link and put a link in the video description of walkthrough of these cleanup policies for the container registry. But we can have a look, a quick look here. So cleanup policies. So at its core, we let users define a set of filters, and those filters, we apply them on all the container repositories of a given project. And like some of the filters will say, hey, tags that are that match these filters, we can remove them. That's because the container registry, to store the images and the tags, it will use object storage. So that's a usage on the object storage. So users need a way to manage that storage efficiently, and one of them is the cleanup policies. Yeah, I will not go over all the rules, but for example, one of them is tags that are like older than 2 years old, we can remove them. How can we know that the tag is 2 years old? Well, it's easy in the sense that here in the GitLab API, we do also have the same thing on the Docker API, but it's a bit more involved. But well, the main thing is that we do have a created at timestamp. So we can know when this was created, and we can have a rule, okay, tags that were created like 2 years ago, we are quite sure that we will not use them anymore, so we can automatically remove them. So that's the part where you can define filters. The other part is executing the cleanup policy. And for that, we use several background jobs. They are all based on the limited capacity concern. But in a way, they detect that a policy is ready to be executed for a given project. And then it will try to, well, not try, it will execute the policy. The challenge here is that, and you can see what we were discussing at the beginning, is that we are working at the tag level. So there is no way that those background jobs can do the cleanup without contacting the container registry. That's impossible. We do have the container repositories, but we don't know like how many tags there are behind and which are the ones that we can clean up. No way. We need to call the container registry on the GitLab API, and then we will get back the tags. Then we can analyze the tags and select those that can be deleted. So it's a pretty complex job because of this interaction with the container registry. I guess I will not go into more details. You will have all the explanations here, and there is also a page on the development side. Let me show you. I think we do have something for this. Let me see. Yeah, feature development. Yeah, I'm not sure we'll have it right away. Package. Yeah. Is this one? Yes, it is. So it's this page. I will drop a link in the video description. So this is the technical description of those jobs. You can see here the limited capacity job and what are the services that are called and anything. Actually, we can see the delete tag service, which is the facade being called, because this job has to work with both APIs, right? So we have we use the facade. We don't use like the specific delete tag service for GitLab or for third party. We use the facade directly. This is Yeah, I will let you check the technical description. It's pretty complex because we do have quite many parameters. Can I show you an example? Yes, I can. Very quick so that we are done with the cleanup policies. Here. So, yeah. So this is the settings of a project. So you have a project settings, you have packages and registries, you have cleanup policies, and you have the rules. And here are the rules. Like it's basically in two parts. What are the tags that we will always keep, meaning that those tags that match those filters will never, never, never be removed. And even if they match this section. It's like a protected tag or something like that. And then we have the filters to select the tags to remove. So you can see that we have the older than, and we can match using the names using regex. So that's pretty complex. Have a look at the jobs implementation if you want to have more details. But that's a big part on the Rails side, and it's challenging due to how the data is organized, and we don't have everything on the Rails side. You can see the difference between the cleanup policies for container registry here and the cleanup policies for package registry, where in this time around, we have everything in the database in the Rails side. So executing a cleanup rule, it's as easy as like selecting all the packages on the database and then just mark them for destruction. So it's way more easier. Yeah, not so much anything else for this part. Do you have any questions?
Yeah, maybe question on why they weren't implemented in the container registry instead of Rails. I mean,
Yeah.
since it's easier to retrieve the
Yeah.
data. Yeah.
Good question. I would say that at some point they will get moved to the container registry, because the container registry is like the source of truth of all the data. So it is way better geared to execute cleanup policies, and Rails can drive them. For example, you can imagine having the UI and everything to manage the parameters. And once you save the policy, you send that save to the container registry saying, hey, this is the policy that we want to use here. And then the container registry will do its thing. I would say that it was a capacity and a focus from the team. That's a good bridge for my last point. I wanted to show you what we have done the last 2-3 years. Yeah, on the container registry. They have been focusing on garbage collection. That was a very, very high SSL subject, and so they did everything on. They focused entirely their efforts on that subject. So, like, policies were working on the Rails side, so we didn't move them. At some point, I think this discussion will happen, and yeah, I would be in favor to moving them to the container registry. The other thing is that the container registry is, I guess that's something I should have mentioned in the beginning. It's a backend that is different from Rails, and it's a backend in Golang. So they don't have all the like bells and whistles that we have in the Rails backend. Like, for example, like everything that we have around Sidekick and the limited capacity job, like with an application setting, you can easily manage or tweak the amount of jobs that run in parallel for this execution. Things like that. So like there is work to do to implement this. It's not just as simple as, hey, let's do a background job and let's execute those policies. It might have more work, but that's the container registry side. It could be a good question to ask them in a coffee chat. I think at some point the discussion will happen. And yeah, for me, definitely the policies need to be moved on the container registry side. The other thing, I guess, the other problem is that what do you do with third-party container registries? Because they will not implement them, right? If you have a self-managed user that uses the like Amazon container registry or the Google container registry, they will not have policies. And these policies, at least they have the benefit of working with those third-party container registries. So I guess there is also a product perspective here and some product questions that need to be answered.
Yeah, thank you.
All right. Yeah, the last thing I wanted to discuss is what we did. It was mainly last year. Took a good amount of time last year on the real side for the container registry. That is what we call the data migration on the GitLab container registry. So I will simplify things here to go a bit faster because it's things on the container registry. Basically, it's a registry, so they need to handle files, right? They get not files, but like bytes. You can imagine bytes or blobs if you want. They actually have this definition, like a blob object, so a set of bytes. So they need to receive them, store them somewhere, which in this case it's object storage. And then when we delete them, well, it would be nice to remove them from object storage, right? Because it's taking space, and well, space on object storage is certainly not free. So the problem is that at the beginning, the container registry, the GitLab container registry, which is actually the like container registry, it's a fork of the container registry that Docker open sourced. So it's a fork of that. They work with the file system. Like there was no Redis, no database, nothing. It was a file system. So like looking for a tag to delete, you need to go through the file system. So, well, no problem when you have a few like blobs to delete or to handle, but imagine that you have millions and millions and millions of objects on file storage. That traversal of going through the file storage, that has a hefty price. So what they did, and I'm simplifying here things, is that when they receive a delete, they will not delete from the object storage directly. Instead, they will like mark the object as, hey, this has been destroyed. And so they will mark different objects as destroyed. And then they have this command that is called the garbage collection or garbage collector that you would run, and it will like walk through the file system to find those marked objects so that they can remove them from object storage. The problem is that this garbage collector has to be executed offline. There is no way to run it online. So you can imagine that this restriction will not work well or not at all with GitLab.com, right? And it's actually quite long. Traversing a file system can take a bit of time. Yeah, like a bit of time, like a few days to execute the command. So having the container registry offline for a few days, no way for GitLab.com. So they needed, or we needed, actually, we are all the same team. We needed a way to have an online garbage collector, meaning that the garbage collector could check what are the marked objects and remove them from object storage without requiring the container registry to be offline. To do that, there is no way. Well, I don't have the details, but like the file system will not go through. It was impossible. So the idea was to have a database and like properly organize data in the database. So what we did most of the last year was moving or migrating. We heard like the container registry data migration, moving objects from the file system side to the database, so that then in the database it's way easier to find those marked objects and remove them. So we needed that database migration first. And that's actually what we did last year. That migration was driven by Rails. So it was Rails that had the it was the orchestrator, if you want, or the driver of this. So it would take a container repository and then ask the container registry, hey, was this migrated? No. Okay, so can you start the migration? And the migration was actually a two-step process for the container registry. It was not like in one go, because again, you see a container repository, but you could have like thousands and thousands of tags behind in the container registry. So that takes time. And so the container registry would then contact Rails to say, hey, this container repository was migrated. And so it's like it's done. And the Rails part would walk through all the container repositories that Rails knows to migrate them. That took a good amount of time. But you can see in the code, we can still have, we still have some things about the import. Like, for example, this function, try import, that's the function that will like send the start migration command to the container registry. Yeah, you can see, I think we used a state machine, where it is, here. You have a migration state. Because as I said, the migration is in two steps. It's not a single one. There was a pre-import and there was an import. So we had many steps defined, many events, and you can still see the code of this data migration in the code on the Rails side. The migration was completely fully done for .com, and for self-manage, if I'm not wrong, they will not use what we did on .com. They will use something else. So I think it's basically a command like bringing offline the container registry, migrate it in one go, and then starting the registry again, which was impossible for .com, right? So we did this all while the registry was online. We had fun. It was actually the first time that both teams worked really together. Like we were investigating logs, like what happened on this repository. Oh yeah, this happened on the Rails side. What happens on your side on the GitLab container registry? So we had fun, but all went well. And .com is fully migrated. And any new container repository that is created now, it's created directly as migrated, like directly in the container registry database. And that database actually unlocked several features. One of them is the GitLab API endpoints. The tags endpoints that we discussed with pagination, that was possible because tags are now in the database. And so, well, pagination in the database is quite easier, well, quite more or less easy to do. And they were able to create this online garbage collector. So we have an online garbage collector that runs all the time, and all the time it will like reclaim all the storage from object storage. They have a few dashboards for that on Grafana. So on the container registry side, feel free to explore them if you want. That's what the main focus of the container registry team was. And that's why the cleanup policy is, yeah, we discussed about moving them, but there was never, okay, we now have time to do this. It's like, no, the online garbage collector is like the highest priority. And that would be the end of the container registry side. Do you have any questions?
Yeah, just curious, that garbage collector is written in Go, right?
Yeah, that's all written like within the container registry, and that's specific to the GitLab container registry. Like all the other container registries, I don't know if they have an online garbage collector or not. I have no idea, but the open source container registry provided by Docker doesn't have an online one. It's an offline one. You need to like put the container registry in read-only, and then you can run the offline garbage collector. Right?
Yeah.
I hope your heads are not exploding. too much data in a short amount of time. Okay, I will take just a few minutes for the dependency proxy, and then I guess we are good. So the dependency proxy, yeah, there is vastly a pretty good confusion. Like the dependency proxy has something to do with the container registry feature. And the truth is that nope, not at all. But it's related. That's correct, but it's not the same thing. So the container registry, oh no, don't say me that my mouse is dying now. No, we are still here. The dependency proxy is basically this, a pull-through cache, meaning that you will have Docker, you will have, well, at the moment it's Docker Hub, and you have GitLab in the middle. When Docker pulls an image from Docker Hub, it will pull, it will send a request to GitLab. GitLab will send a request to Docker Hub. Docker Hub will reply the image or tag or whatever object you request. GitLab sees that the object and returns it to Docker. So you see, there is no GitLab container registry in that interaction, but it's related in the sense that Docker will pull objects with the same API commands or whatever you want to call it as if it was pulling from the GitLab container registry. It's the same API, because for Docker it's, hey, let's say that it's, hey, I want to pull a blob or an image. The commands that are triggered by this client, this Docker client, it's exactly the same for the dependency proxy and the GitLab container registry. So we do have this on GitLab Rails, the dependency proxy. And what is interesting is this word cache, meaning that we see the objects going back to the client, but we are not going to send the objects back to the client, because otherwise we are doing a proxy feature, but without like a lot of value, right? So what we do is that we send the object back to the client, but at the same time we save it in a cache, which is actually object storage. It's a file on object storage. This way, next time we see the exact same request to the same object, instead of like pinging Docker Hub and returning it from Docker Hub, we can just use the cache and return the cache. That's a way to, for example, mitigate the Docker Hub rate limits. I'm not sure if you are aware, but well, Docker Hub introduced some pretty restrictive rate limits, meaning that if you pull too many images per hour, at some point they will not be happy with that, I guess. No, you will reach a limit and those pools will not work anymore. So with the dependency proxy, you can cache those heavily accessed images and you can remove them from the rate limit computation of Docker Hub because you are pulling them from the cache directly. So because we are using a Docker client, same thing for authentication, exactly same thing. As I said, the client will try to like pull a thing from Docker Hub using GitLab, and well, GitLab will say, hey, no, you need to be authenticated. So use this controller, which is the JSON Web Token controller, and that's why you have a service, an authentication service for the dependency proxy. Yeah, again, nothing too magical. It's really similar. The dependency proxy works at the group level. So we receive the group, we receive the user, and we receive the action, and then we will map that to a permission. I think it's read dependency proxy, if I'm not wrong. But yes, we can just check really quick. Full AC. And here we have read dependency proxy. Yeah, that's the permission. So it will get a token from that, and then it will ask the it will use that token to do the pull. It's only for pulling, right? The dependency proxy doesn't work for pushing images. Actually, that doesn't make a lot of sense, but it's really for pulling only. So I think, let me see, it's dependency proxy group. Yeah, that's the one. Don't ask me why they use this name. It's before my time, but it's all done with a controller, and that's it. So basically, there is only two routes: the manifest and the blob, which is the two like row types that container registries will work with. And so both work in the similar way, in the sense that we are going to check Docker Hub. I think there is a head request that we do to check the digest, the signature, and check if we have a cache with that object, and check that the cache has the same signature. If that's the case, then we send directly the manifest. And if that's not the case, we actually this is a super smart action that workhorse can do. You can tell workhorse, which is the component that is in front of Rails, to say, hey, I want you to return this URL or this data that is on this URL, but at the same time, you upload it to this URL. So you can imagine the T command in Linux, like where you can like split the outputs. Well, this is the same thing, but with data that is located in a URL, and it is like pull the data from this URL and then you T it. So one stream for the actual client and another stream for the upload, and that's when we are going to create the cache object. So we do have cache objects. So those are, if I'm not wrong, it's dependency proxy blob. It is here. So we do have a blob and we do have the manifest, and both have a file uploader. So that means that we have a link to a file on object storage. That's pretty much the whole dependency proxy. The only other thing that you need to know is that with time, users will start building a lot of cache entries, and those cache entries are stored on object storage. So same thing as the container registry, if you want. It is using object storage. So we do have like a simplified cleanup policy. It's super simple. I think it's only one rule, and it's the amount of days that this entry was not downloaded. So for example, here, this means that, hey, if this blob or this manifest from the cache was not downloaded after 90 days, you can remove it. And that's it. That's the whole cleanup policy. So this is way more simpler than cleanup policy for container registries, because we do have like everything in the database, and it's just one rule, and that's it. There is also a way to like remove all the cache in one go. It's like a reset, and you can use that too. Is there anything else I want to show? Yeah, we could have a look at the, let me see if I find, we do. So it works at the group level. Don't make the same mistake as me. Like I was looking at the project and I was, where are the dependency proxy settings? I don't see them. And yeah, I will not disclose how much time I lost that day, but yeah, that was a pretty high amount of time. So don't do that mistake as me. It works on a group. You need to be at a group. You see it there. So you can see the images that were cached. You see here when it was cached. And the other things is that we do have some settings, which is basically like enabling the cleanup policy or not, and enabling or disabling the dependency proxy. So it's very similar to the package registry and the container registry, but it's a very simplified version of it. Yeah, apart from that, it's nothing too magical. It's really a cache. Like we put GitLab in the middle of web request, and we use this opportunity to cache responses so that we can save some requests to the actual registry. Last word on this is that we are currently at this point of time, we are currently working on a similar feature for package registries, and we are starting with Maven. So same thing, we want to be able to target a Maven package registry and put GitLab in the middle, so that when the Maven client asks for a package and that package is in the cache, we can return it right away. We don't need to ping the external package registry. And that's about it for the dependency proxy. Do you have any questions? Yeah, it was quite quick, but really it's like you see the controller. The controller is actually two routes. That's it. Like, well, okay, no two routes. It's like for clients, it's two routes. For the Rails backend, it's a bit more because you need the routes for uploading objects, because this magic trick with workhorse will upload things, so it needs a route to upload objects, and that's where we put blobs and manifests to object storage. But from a client perspective, it's really like 2 routes. That's it. And so it's like nothing magical. Don't be confused that, hey, the dependency proxy is a thing that is working on the container registry, or you interact with the container registry. No, not at all. It's different, but it used the same commands, the same objects, and you actually log in the dependency proxy the same way you log in the container registry. We can see that here. Yeah, you see, you need to Docker login, and then you actually log into the base URL. So that's the thing that is a bit confusing. You don't log in into the container registry or the GitLab container registry. You actually log in into the Rails application, not the GitLab container registry, because this is all with the Rails application. Okay, you made this far, so congratulations. That was a lot of information. I went over time and yeah, everything. So congratulations, or well, better said, thank you for bearing with me. Yeah, again, I will try to post the interesting links in the video description of this recording.
Thank you.
Okay, well, if there is no other questions, I guess we are.
I have a
Oh, yeah.
probably stupid question. Probably it's way earlier. I should have asked.
There are no stupid questions. That concept doesn't exist. It's like no.
The
Well,
container registry and the dependency proxy, they keep their state in the same database that the Rails application talks to?
no,
Or
no. That's the thing. The dependency proxy is really, it's like a feature of the Rails backend. And so it will use the Rails database and everything. And it's, in a way, it is a container registry in disguise, because we need to interact with the Docker client. I guess we can have a parallel with the dependency proxy for packages. We are starting with Maven, so that dependency proxy will need to speak the Maven API, meaning that when you pull a Maven file with the the structure that Maven clients we use, that dependency proxy will need to understand that structure. So same thing here, the dependency proxy for Docker images need to understand, oh, this is a Docker client, or well, a client doesn't need to know that it's Docker. That's a client that is pulling a blob. Okay, so let me do my thing to pull this blob. So it's really all contained in the Rails backend. It's a Rails backend feature. The container registry, it's the other backend that is running. And in particular, that's actually a good question. The database of the container registry is like specific for the container registry. We don't have any access from the Rails backend. Yeah, we had some discussions if it would be a good idea to provide Rails a read-only access to that database, so that we can, this way Rails has a way to know the container repositories and the tags without pinging the container registry. Yeah, I guess the discussion went like, well, we are going to build the database first, and then we'll see. But the problem is, again, we are supporting third-party registries that will not have this database part. And so you will need to gate this part in the Rails backend for the GitLab container registry only. But yeah, if you look at the Postgres.ai tool that we have, you will have GitLab Rails, and there is an instance that is for the container registry. That's the container registry database, or metadata database that sometimes they call it that way. But it's really disconnected. That's why it's challenging to work or to have those changes on those features with the container registry, because if you look at the Rails backend only, we only have the container repositories, and that's it.
Yeah.
Okay. Well, I guess if there are no more questions, thanks for attending, and yeah, I guess I will see you in the next one, and have a great day. Bye bye.